A woman walk, her entire weight is momentarily placed on one heel of her high-heeled shoes. Calculate. Now they're talking about the pressure. You can see she is balancing her overall weight
Mhm.
just on the heel. Calculate the pressure exerted on the floor by the heel if it has an area of 1.5 cm square and woman's mass 0 kg. Express the pressure in Pascal. In the early days, that is actually the thing just for you. In the early days of the commercial flight, women were not allowed to wear the high heels shoes because aircraft floors were too thin to withstand such as a large pressure. Okay, fine. We have the relation for the pressure. E is equal to F over A, but as on the heel, the pressure is just because of the weight of that woman that she is balancing over A is equal to mass is 60 multiplied by uh, G is 9.8 divided by area is 1.5 cm square, but you need to convert it into the m square. For that purpose, you need to multiply it with the 10 raised power minus 4. As a result, the value of the pressure that we have here is 3.92 cross 10 raised power 6 Pascal. And if you want to write it in the megapascal, then it will become 3.92 megapascal. So that is the answer. It was a very simple question.
That was
Uh,
one of my favorite questions we've ever done. That was so short.
okay, because it was actually according to you. Okay, fine. So pressure P is equal to mg over A, putting the value, simplifying. Scientists or the book writer are intelligent. They're actually forcing us to solve the question, and in the solving the question, they're also giving you a learning message.
Yes.
Okay, so we have on the question number 9, the greatest ocean depth on the earth is are found in the Marianas Trench near the Philippines. Calculate the pressure due to the ocean at the bottom of this trench. We have to calculate the at the bottom of this trench whose depth is 11 kilometer. Assume the density of the seawater is constant all the way down. Density is constant. Density of the water is always constant. That is, 1000 kilogram per meter cube. And depth is actually here considered height is equal to 11 km is equal to 1100,000, sorry, 1000 meter. And about density is talking, but we know the density is 1000 kilogram per meter cube. And one thing more that we have, what we have to calculate pressure at the bottom. We have to calculate pressure at the bottom. So for the pressure, we have the simple relation P is equal to rho G H. It is very bad P. Okay, fine. 1000 multiplied by 9.8 multiplied by 11,000. Yes, which will result 1.078 multiplied by 10 raised power 8 Pascal. And after rounding it off, you can write 1.1 plus 10 raised power 8 Pascal is equal to P pressure. So the pressure is 1.1 kilocentimeters per 8 Pascal. It is actually on the deepest part in the world, in the ocean. That is 1.1 kilocentimeters per 8 Pascal. And previously, there was an incident about which you have listened in the news that in the Titan, a family was moving to wash the destroyed part of the Titanic
Hmm.
in the deep sea. And that Titan submarine was destroyed just because it was unable to face such a high pressure.
Hmm. That was very interesting.
So it is very difficult. In other words, we can say impossible just because without protection, if you want to move at this such a pressure, it is impossible for you to survive there.
Hmm.
Okay.
Yes,
Okay. That was question number 9.
that was also a great question.
Okay. Here you can see height, density. You have to calculate the pressure. Pressure is equal to rho gh. Put the values, calculate the pressure. So now we are on the question number 10. After that, there will be the last question.
Wonderful.
Okay. Explain what happens when you drink through a straw. You can't drink water through arbitrarily tall straw no matter how hard you suck. Okay, fine. Suppose we have a straw like this. As we suck some liquid like a juice, then our a little bit we compress our cheeks like this.
Hmm.
Just we actually reduce our internal pressure within the mouth. As a result, due to the atmospheric pressure on the pipe on the straw, liquid move up in our mouth and we suck and enjoy. But here the question is different. If it has more length, then it is not possible just for you to suck the liquid in your mouth. So why you can't drink the water through arbitrarily tall straw, no matter how hard you suck? We have to discuss it. By reducing pressure in your mouth, atmospheric pressure on the liquid surface outside pushes the liquid up in the straw. That is actually the rule to suck the water in the straw.
Hmm.
But our question is different. For the long length straw, you are unable to suck the liquid. Why? Let us calculate how much can be this length. Maximum possible height when the hydrostatic pressure of the liquid column rho gh equals the atmospheric pressure. So for water, maximum height H maximum is equal to pressure P over rho g. It is actually from the equation P is equal to rho gh. This equation is just simplified.
Hmm.
Atmospheric pressure is 101,325 divided by, as we are talking about the liquid, we can use the density of the water 1000 multiplied by 9.8 and it will result almost 10.3 meter height. 10.3 meter height or the length of the straw is actually the limit at which you are unable to suck the liquid into your mouth. Beyond that, no matter how hard you suck, water cannot rise higher because pressure at the top would be zero. Perfect vacuum. So tall vacuum fails. You are actually just want to suck the liquid with your full power, but you don't have the enough power that can suck the liquid from 10-meter lengthy pipe. As a result, on the top of the pipe, there is actually the perfect space like the vacuum. So in this way, there is a disconnection procedure from that liquid and from the pressure reduced in your mouth. As a result, you are unable to suck the liquid. Is it clear?
Yes, it's clear.
Okay, it is actually a theoretical question and whose calculation a little bit is here.
Hmm.
Okay, so we have the last question now. After that, you can bring a cake and cut and celebrate.
Yes. I'm
Okay.
definitely happy about this.
A typical adult giraffe mouth is 2 to 2.5 meter below is its mouth. Mouth below its mouth. Actually, he's talking the food reached
Yeah.
2 to 2.5 meter away from its mouth. It is the actual position of the food. Its mouth when the giraffe wants to drink. How do you think it's proceed? How he will drink? We need to think. Try to estimate the validity of your scenario. This is the question that is depend on our scenario. We have to decide how he will try. Could you estimate a daily giraffe water need? Also, we need to estimate the daily drunk water by the graph. Is your scenario compatible with this amount? The scenario that you will choose may be compatible, maybe not. We are not actually that, but it is actually the way of the some type of the practical. But let us check what can we do in this case.
Mhm.
Okay, giraffe mouth is 2.5 meter below. It's hard when drinking. Heart must pump below. That is actually a distance 2 to 2.5 meter from its heart and mouth distance. And during drinking water, heart must pump blood against the gravity increase when head is down. Head is down. Now head or the heart is need to pump the blood upward against the gravity. But if it is straight up, now it is pump the blood just below towards the gravity. Now in this case, during the drinking water position, he need to pump the blood just above against the gravity. That is the first case.
Mhm.
Let us estimate the water need he want to drink on the daily basis. For that purpose, we consider the graph mass is equal to 1000 kg. Actually, previously we have solved a question of the elephant about which we used Kepler's laws by a factor of the mass of the elephant to the mass of the person to raise power 3 by 4. That was actually the formula for the factor. First we calculated that factor and then we multiplied the supposed value of the water or the food in the calories per day. That was a 2000 for the 70 kg man, and we multiplied and calculated. Also we are applying the same scenario. There is according to the mass, I think a little bit they are closer, elephant and the giraffe, to each other according to the math.
Yes.
Okay, fine. So what was the Kepler's law? That was that uh, graph water is proportional to the ratio of the mass factor, and here we can consider that it is a mass of the graph. Mass of the man is 70 kg. Mass of the man, and this man is on the daily basis drinking the water almost 2 liter per day. We need to estimate the water for the giraffe. So giraffe water, just shortly I'm writing GW. Giraffe water is equal to 2 multiplied by ratio of their masses. Mass of giraffe divided by mass of man to raise power 3 by 4. That is actually 0.75 actually. So let us put the value 2 multiplied by 1000. Oh, previously it was actually, I remember, 7 pound and 7000 kg of the mass of the elephant, but here it is 1000 just. Okay, fine. Trace power 3 by 4, and it will results 2 multiplied by 7.31 is equal to 14.6 liter per day. So according to our this calculation, giraffe is taking the water 14.61 per day. And whatever we will suppose, it will not a mistake, because just we are having a lab type of work and calculating the results. Okay, but giraffe drink water on the daily basis 10 to 30 liter on the daily basis. Giraffe is drinking water. That is actual almost amount. That is a predicted or supposed or observed amount of the water. Someone in the zoo can observe only.
Hmm.
Okay. So, but giraffe drinks 10 to 30 liter per day depending on the vegetation's moisture content. What he is actually taking as a vegetations. So it depends on that. Just we are actually in this question discussing the mechanism. Now let us the mechanism discuss. Strong blood vessels value in neck veins to prevent backflow. He is drinking, and strong vessels and strong veins in the neck will prevent him to backflow, and high blood pressure when upright to perfuse the brain. And in this way, blood pressure will be high. When head down, adoption prevent excess blood pressure in the head in that case. And drinking physically possible because straw effect does not mouth straw effect does not limit them. Physically it is possible, straw effect is not enough for limit them. This submerge mouth and create suction or the simple draw water in by lowering head and below the surface. That is a little bit mechanism that we are here supposed how he will drink the water and how much the water can be drunk by the giraffe on the daily basis. That was actually a little bit discussion on it.
Hmm.
So now we have ended our work, and
Amazing.
you can
Thank
be
you so
happy.
much.
Okay, you're welcome. You're welcome.